All right, ladies, we're going to do day 3 notes, equations. So typically, this is not solving equations. It's really one variable and doing the order of operations. So we know what an open sentence is. It's also called an expression, okay? An open expression doesn't have an equal sign, okay? And then when it does have an equal sign, we call it an equation. So yes, next chapter we'll be solving equations like this, but for now we're just going to continue with the order of operations and to just recognize what can be a solution or not a solution to an equation. So determine whether the given number is a solution of the equation. So I have y is equal to 14. I'm going to plug that into here. And is this a true equation? 12 plus, I put 16. 12 plus 14, is that 26? Yes. Solution. Okay, next one. I didn't give myself a lot of space, did I? All right, go ahead and try that one. B, I'm going to take the 3, multiply it by the 2, plus 7 equals negative 5. Automatically, I can already see that no, it's not a solution because the left side is all positive. That's 6 plus 7 equals negative 5. And 6 plus 7 is 13. And 13 does not equal negative 5. So no, not a solution. This last one here. Again, order of operations, negative 11 minus 4 divided by 5. Does that equal negative 3? So negative 11 minus 4 is negative 15. Divided by 5, does that equal negative 3? Yes. So it is a solution. So again, most of you know how to solve equations. You isolate the variable to make sure you solve. They are solved. Some equations have unique solutions. In contrast, others have no solution or infinite many solutions. So in question 1C, the unique solution for that equation was negative 11, all right? So we're going to solve the following equations and state if there's one solution, no solution, or infinite. Or identity is what we call infinite solutions. So again, you see it's just the order of operations here. T is equal to, let's go ahead and evaluate. We could evaluate 9 squared, and then that's 5 minus 2, which is 3. So T is equal to 9 squared is 81 divided by 3. And so T is equal to 27. So this is one solution. T is equal to 27. All right. Now down here, let's go ahead and evaluate the inside there. 7 minus 16 minus 10 plus n is equal to 10. 7 minus 4 plus n is equal to 10. And 7 minus 4 is 3 plus n is equal to 10. And most of you would sit here and subtract the 3, but we'll be doing this next chapter. So in this case, I just ask myself, 3 plus what equals 10? So n is equal to 7, and that's one solution. All right. So we got stuff on the left and stuff on the right. I'm going to go ahead and evaluate everything here on the left. 5 times n plus 6. And then on the right, we have 5n plus 7. So in this case, are these two sides the same? No. So therefore, we say it's no solution. And down the line, yes, we'll eliminate the variables and we'll be left with two constants which do not equal each other, meaning it's no solution. So we'll look at an example that it actually ends up being the same expression on both sides. All right. So we have 10 minus 7, which is 3, and then so 12 times 3 plus 9g is equal to, and I'm going to evaluate that inside, 2 squared plus 5 is 9, so that's 9g plus 36. 12 times 3 is 36 plus, ooh, look, I put 996 there, not 9g. I was thinking ahead. 9g is equal to 9g plus 36. Okay? Are they identical? If we use the commutative property, we can switch these around. Oh, they are identical. That's why we call it an identity. Because these are identical. Okay? And identity also means infinite solutions. I don't know why I switch up from manuscript to cursive so often. All right, makes sense? So these are two special cases, this one and this one, right? The special cases. And then we have the unique solutions. Okay, this extended practice we're going to do, I believe in class is probably the best. You can go ahead and try it on your own though, if you'd like. And we'll just see what you get. And we'll discuss it at the beginning of next class. All right.